Howdy, Chemistry 116. This is the group of Emilia Axworthy, William Knox, and Allison, and this is our spectrophotometer video.
Throughout this experiment, you will be using a spectrophotometer to help measure the absorbance and concentrations of the solutions. The spectrophotometer is imperative in measuring across all different wavelengths, which is important for two different situations. Number one, if you are ever using solutions that have different colors or wavelengths, it is important to scan from 800 to 200 nanometers to account for the wide variety of differences. Scanning across all wavelengths can also help you identify what an unknown solution is. By reading the absorptions of different solutions, a spectrophotometer can be used to match an unknown to a known. Next, we must relate all this to how it helps us find our lambda max. A lambda max is the point or wavelength in which a solution reaches its highest level of absorption of light. By scanning across all wavelengths, we are also identifying our lambda max, which can be used for finding the concentration of solutions and qualitative identification of different substances. When performing a scan on all wavelengths, you will see a graph that shows how much light is absorbed at every wavelength.
In Beer-Lambert law, there's 4 different variables. A stands for absorbance, and it is calculated using this formula. The Greek letter epsilon is the molar absorptivity, and it depends on the chemical composition of the solute and wavelength chosen for measurement. B is the path length. It is determined by measuring how far light travels through the solution. And C stands for concentration, which is measured using a spectrophotometer. Concentration and absorption are inversely related. When one goes up, the other goes down. If you fail to zero the spectrophotometer, it will affect the concentration of the other samples because it does not have the proper read of the blank.
Before heading into the spectrophotometer room, you must first transfer your solution into the cuvette, filling it carefully so that the meniscus rests on the line. Make sure to remove one glove before going into the room. When using the spectrophotometer, you must first take your blank and wipe it before inserting it into the machine and zeroing. Next, add the cuvette with your solution into the chamber, making sure to wipe it well. Close the spectrophotometer and scan the absorbance. After recording the data in the notebook, carefully remove the cuvette and close the door. Repeat for each cuvette. Before leaving the room, be sure to clean the area around the spectrophotometer.